What's up, nerds? We're back doing 5.2, continuing on definite integrals.
Baller. Yeah. Love the clapping. I don't usually get a clap though. Throwing it out there. All right. So for today, you guys have been thinking about it, and I will write normal size, but when I copied and pasted it, it came out this small. So sorry about that. We get one more theorem. So we saw yesterday that if a function is continuous, then it's integrable. And I know that's an ugly word, but we can take the integral of it. If it has finite discontinuities, which if we want and if we need, should we really truly expand on what this means to be a finite discontinuity? There's two types of discontinuities that one would consider finite. Talk with your neighbors real quick. Let's get both of them. I heard one of them. Did you get the other one too? Boom. All right. So if you guys don't have it yet, huge shout out to Abigail and Angel. We have two types. We have removable discontinuities. If you need this, jot it down. It's just a nice review, which would be a factor that divides out, right? There's a hole in the graph. We can literally remove that point when we divide it out. Okay. We have removable discontinuities. And what was the other one? Jump. Okay, those are our two finite discontinuities. The other one is when we approach an asymptote and we shoot up to infinity. All right, the last property that we get before we just start rocking some of these bad boys. Just kidding. There's only one more. Here we go. Okay, theorem, last one, and I'm gonna write this one normal sized. Why does this look so weird? Ink flow and bold. There we go. Okay, does it look blurry to you guys? That doesn't. Weird. It did initially. I don't know. All right, check it out. If we run into the situation where we have some function f of x that just happens to be some constant, and we're going to call it h, and there's a reason we're going to call it h. But if you give me this function, then if we were to take the integral, we'll say then, if we were to take the integral from a to b of f of x with respect to x, which we're going to take a quick vote. With respect to x is the more formal and appropriate way to say it. Anybody opposed to if we just commit every time to say dx? Okay, I'm good with that. Okay, this would be the exact same thing as the integral from a to b of h, I think, because we would just do a little bit of substitution since that's what f of x is, dx. And then let's think about this. And on this margin of your page is where I'd like you to work. I want you to draw roughly the graph of some line, y equals h, some number, from a to b. And I want you to see if you and your neighbor, can you come up with the area of that? So you're going to have off on the margin on the side, I need you somewhere on this to graph the line y equals h from a to b. And I want you and your neighbor, we'll spend about 60 seconds, see if we can't come up with what the clear formula for this is. Good. So what does the graph of like a y equals a number look like? Like y equals 2, what would that look like? Cool, so let's call it h and draw that line. Like, I'm fine with that. Let's call it h. Yeah, just anywhere is fine. Love what you're doing so far. If it helps, I would encourage move dashed line straight up from A and B on your axis. You can see the shape that you're finding the area of. And I'll sketch because I see most people up here have the same thing. Here's the line y equals h. Cool. Or f of x equals h. Now we're finding the area of this shape, right? Like that's what we're after with the integral. What shape did we just do? Now forget the calculus for just 30 seconds. How do you find the area of this rectangle? Base times height. The height is h everywhere. I know that to be true. What's the base of this rectangle? B minus a. Okay. We have a convenient way to work out if we get the integral of a constant, apparently. It's going to be really nice and easy to think about. So we have 2 problems to do today. After the first one, we're going to come back together and we're going to be doing some infinity stuff today. Everybody has a bookmark, I think? Okay. So rather than just making you guys watch me, I want you guys talking these out with one another. I'm cool if you do it in your notes, but as I'm walking around eavesdropping in all y'all's conversations, I need to hear everybody speaking at one point or another. Cool, cool? All right. So check it out in your notes. I'm going to give you guys a head start on this. Do we have any questions about any of these 3 theorems? Any of them seem unreasonable? Obvious or no? Your faces sure aren't obvious with answers, just so you know. Maybe not. We'll see. Well, let's see how it shakes out. Okay, I would have your bookmarks ready. I want you to do one more for me. You are going to evaluate the integral, and I'll just give you the integral here. The integral from, let's say, 2 to 5 of x squared dx using the limit of Riemann sums. Okay, before I just pause the video and cut you guys loose, check with your neighbors, see if you need a push to start or if not. I'm going to give you guys like a second to decide if you need one little more piece of information before I just let you solve it. Chat it out, see if you guys can come up with an approach. I just offered you one. I actually do not have another one right now, but I'll print another one. Okay. I will print a whole bunch more of them. Okay, so based on the fact that everybody seems to be just starting to work, I'm going to say we don't need the extra push if you have your check mark. Or if you do and you don't want to say it right now, you can just get my attention as soon as I pause this video and we can chat about stuff. Cool. I'm going to give you guys a couple minutes. This one, Alex, just so you know, the other day when I shut you down when you're doing all the end stuff, this is one where you want to do the end stuff. Okay, cool. What do we need? There's 3 things that we're going to find like every time. I need C sub I. And how do we find C sub I? A plus delta xi is the standard way to do it. Are we using right or left points? And they're so much nicer. Could we use left endpoints? Yeah, but if we're going to do it infinitely many times, then what? It doesn't matter. Let's pick the easy one. Okay, so I need C sub I. What else? I need delta x, which I hope is 3 over n. And there's one more thing I need. F of C sub I. And last question, is anybody in here a freshman? Okay, so I don't believe you. But okay, so check it out. The freshman part of it comes from this expression, 100%. It is natural when you see 2 plus 3 over ni squared that you want to just square both parts. But let's not fall for that trap. We have to actually multiply it. At this point, I've identified the 3 things that you guys told me. Here's delta x, C sub I, and f of C sub I. And then right here is S sub n. This is the actual summation. I'm not going to write the limit over and over and over unless I want to make sure I write it like the next 10 times I write it. I'll just do the limit of S sub n after the fact. Okay, this is kind of ugly. And here's where if you are not careful and if you're not thinking a little bit ahead, we're going to get too bogged down in the algebra. It's just going to take too long. So I need suggestions on things that we can do initially. What was your first gut instinct when we have this lovely summation? Everybody think distribute the 3 over n? Okay, so I'm going to do that real quick. So this becomes, if we distribute through, this is now the sum from I equals 1 to n. And I'm going to write really formally, just like we did with derivatives and limits, include the summation until we're done with the sums. So you may skip some steps in here, but this becomes a sum from I equals 1 to n of, and I'm just going to distribute in all 3 of these. Okay, so let's see. The first one is 12 over n. And the second one is 12 over n squared I. Ooh, 36. Good catch. 36 over n squared I. And the last one is 27 over n cubed I squared. Everybody okay with where we're at now? Now this one just doesn't sound as nice, but the summation of a sum is the sum of the summations. And my gut really wants to say the sum of a sum is the sum of the sums, but it doesn't mean anything if we just say it all like that. Okay, so can I split this up into 3 summations? Like that's what I'm gonna do. In the process as well, we need to make sure that we're comfortable writing it a few different ways. I would encourage, do it the way that feels more natural to you. For this first one, because it's like I'm distributing the summation, right, essentially. Do you want me to pull the 12 out, the n out? Do you want me to leave it in there? What would you have me do? Out front and just leave it the sum of blank? Or can I pull, and there's like some variety that we have here. There's 3 options that I see in my head, and I'm going to just highlight them all, and we'll decide which one we're going to go with. I could keep the 12 in and pull a 1 over n out. I could do that. It still says the same thing. I could take neither out and just say that this is 12 over n. That seems less natural to me. Or I could take out a 12 and an n and just leave nothing in here. Which one feels more natural to you guys? The third one feels more natural for you? It does not feel more natural for me. My gut, and I'll use it, I'm fine with that. I would leave the 12 in and I would take the 1 over n out for my brain, but it's going to be the same. I'm okay to take it out here. Okay, that one feels odd. I don't love it, but I'm going to keep it. I prefer the 12 inside. Okay, the next one, what should I take out? 36 over n squared. And it leaves me to determine, I don't know why I switched to green, but sorry about that. What's it inside? Agree. And the last one, what would come out? 27 over n cubed is the best thing that we can take out of there, and it's the sum from I equals 1 to n of I squared. Okay. Questions here? And I lied right to your faces. You don't have to change yours. This is bugging me. And I know I said that I'm going to give you options, but apparently I'm crazier than I thought, so I can't do it. I'm going to leave the 12 inside. It's not going to change the answer in the end. It just, the sum of a constant is one of our rules, and I want to make sure we see the sum of a constant. Okay, so let's do each of these. And I'm going to do them in separate colors only so that we can keep track of it a little bit easier. This one, the very first one, how do you do the sum of a constant? So the 1 over n is still hanging out. It's out front. And 12 what? N. Now, this is not like magically showing up. If you check that bookmark, this is a rule for a constant. It's just 12 plus 12 plus 12 n times. Okay, the second one, and we're going to go with this burnt sienna color is what we'll call that one. The 36 over n squared is still hanging out inside. What is the sum of the first n integers is what we're looking at. N times n plus 1 over 2. Now, if you weren't in class when we started looking at these the other day, reminder, if you keep all your notes from last year, if you go all the way to chapter 7 or 8 and you look up induction proofs, we proved every single one of these last year. Like multiple times, I would bet. Okay, the last one, I don't have memorized, I don't think. N squared, 2n plus 1, and n plus 1 over 12 or 6, one of those. Did I have the first part right? That was not cool. I'm psyched. I know this is usually think, but I want to use it here just so I have some variation. So we get 27 over n cubed out front still, and I am going to check that. Can somebody, I don't have it written down. Somebody read me the I squared sum rule. N squared. It's just n and 2n plus 1. N plus 1 is the other one? Okay. All over 6 or 12? Okay. Okay. We have done the hardest part of this problem so far. Right now is a good point. Check with your neighbor. Like, see, honestly, are there questions that we have? Anything that we didn't understand getting to this point? I'm going to give you 15 seconds. Chat. If everybody's all cool, awesome, but I don't think that's probably really the case. What do you think you did backward?
Oh, I just wrote the summations and go backwards 3 times.
Weird.
Yeah.
Okay.
When do you, at what point of the equation do you start plugging in n's?
So the n, we're gonna clean this up as much as possible, and then I'm gonna actually do this with everybody real quick. Okay, so I just had a question. At what point do we start like plugging stuff in here? And it's a valid question. Here in a minute, we're gonna take the limit as n goes to infinity, so nothing's gonna plug in for n. All we're gonna do is try to clean this up. Now, where people get hung up on this, let me go back. Questions, where were people having issues with these? The algebra, and is it the algebra that's about to happen? Check it out. It's not going to be an issue, and I assure you it's not going to be an issue. In the end, we're going to let n go to what? Infinity. So if there's anything with an n in the denominator bigger than the power of n in the numerator, it's going to go to 0. Like, it will happen, because if it's n squared over n, or n over n squared, I'm sorry, it's going to be 1 over n when we simplify it, and then that would go to 0 in the end. We're going to use that to our advantage. Anybody really want to FOIL all this out? Not a chance. We're not going to, and we're going to see why we don't have to and try to make sense of this. Now, really, really important. I need lots of questions with this, okay? Because when we do this, it's going to look ugly, but I promise it's for your benefit, and we're going to save ourselves like 15 minutes. Okay, so let's just start kicking through. The blue one, is it terrible? How can I rewrite that blue one? 12. Okay, because n and n. Deal. Now, here's the part where if you're zoning out, I need you to stop. I need you to really tune in. When I think about distributing this, 1, ick, but 2, can you guys tell me what the first term would be when we actually distribute all this? Like, do you want, like, we could probably do this if you want, 18, and we'll make that a 1, so it's a little bit nicer. But when I actually think about distributing, do you agree that I'm going to have an 18 times an n at some point? And do I then multiply 18n by n again? So if we FOILed it out, are you okay with agreeing? And I'd like, honestly, not just yes or no. Do you honestly, are you okay if I just say this starts with 18n squared? Have I lost anybody there? Now, here's the weird part. I'm going to sneak my plus in because I'd forgotten it. Is there going to be more stuff behind this? Like, there would be, right? But let's hold off on that. What's my denominator going to be? N squared. In this one, they're going to divide out. Do we agree with that? The next term that I get, is it going to be an n squared? What will the power be on it? N. And if I divided it by n squared, would it simplify to be something over n? So you say no, but pause on that, Raf. I call you Raf, which is weird because everybody calls you Raf, right? I don't know the right way to pronounce it. It's dawned on me like a week ago. Can you clear it up really quick? Sorry. All right, Rafa it is. So what I'm getting at here, and we're going to come back to this, if we did distribute it, we would get 18n squared plus 18n. And I don't want you to actually do this distribution all over n squared. When we clean this up, 18n squared over n squared is just 18, right? What is this one going to give me when I have 18n over n squared? So not yet. 18 over n. Now, Sean said 0, and I know exactly why he said 0, but I want anybody other than Sean to answer it. Why did Sean say 0? When we take the limit here in a minute, that term goes to 0 because we're going to have 18 over infinity, and that's 0. So when we're doing this, the algebra should be the least intimidating part because check it out. I'm just going to say 18n squared plus junk. Don't care what it is. It's all going to get an n in the denominator, and it's all going to go to 0 in the end. Thoughts on that? You can say stuff or smaller, like I don't really care what you write here. And I just write junk because we're not going to use it. The more appropriate math terminology should probably be ... There's stuff there, but I don't really care what it is because it's going to be over n because everything smaller is going to go away when I take the limit. On this next one, let's clean it up. 9 goes into this. Sorry, a 3 goes into this 9 times, and a 3 goes into this twice. When I look at actually distributing. I'm going to have a 9n times 2n would get me what? 18n squared. And then I'm rearranging the FOIL in my head to make it so I'm just doing all the biggest pieces. I have 18n squared times n. That's going to be the biggest thing that comes out of this FOIL, which is an 18n to what power? Cubed. The next thing down the list would be an n squared, right? But everything is going to get divided by an n cubed. So I don't really care about that other stuff because it's just going to be dividing by a bigger value of n in the denominator. This is still all over what number? 2. N cubed specifically. Anything convenient happen here? They gone. And it just is going to turn to 9, I think. So if we go one more little step, I'm going to have the final version. We probably wouldn't normally write this one. We would skip this step, but I'm really trying to make sure we hit it. The final S sub n, before we've taken a limit, is just going to be 12 plus, what is this one going to become? 18 plus, this one's going to be, so you said n, why n? I don't know who said it, unless I misheard. 9, okay, so I just misheard. Okay, now, a couple things I want to notice. Are there any n's left in this? Not really. Now, there kind of are, right? There, don't write these, I just want you to be aware of them. This next one is going to be like an 18 over n, is what's not written there. Because here in a second, when n goes to infinity, what's going to happen with this? It goes to 0. So there's really some stuff here that I just don't care about. So if we get this, now we're about done. We've done the summation. To get the actual integral, we just have to do the what of this. And it's going to feel silly when we write it. Look at your page. It's more than just a summation. We have one more piece to do. The limit. So this is going to seem like super goofy right now. But we're going to take the limit as n approaches what? Infinity. And I see some looks of confusion, but I hope that they're going to be cleared up pretty quickly. 12 plus 18 plus 9. This is what the integral actually is, right? It's a limit of this summation. Why does this feel so dumb to write currently, though? There's no n's. Now, in reality, are there n's here? There are all these other plus pieces that we just didn't write down because they're all going to go to what? 0. Okay, so in the way we write it, there's no n's showing. So let's do the limit. What's 12 plus 18? 30 plus 9? Check it out. We now have, without a doubt, and I'm going to write my answer nicely. So we just got the answer with it. We've simplified everything down. Pretty confident that the integral from 2 to 5 of x squared dx was equal to what? 39. Now, this is correct. We have done it infinitely many times. This part in here is the most hand-wavy, magic-y feeling thing that we do. If you want to FOIL everything out all the time, you be my guest. You can do it. You will never need anything other than the largest power because everything else will fall out. Okay. Easy, hard, like if 1 is, I feel so bad about these, and 5 is, oh, perfect. Where would you put yourself? Okay, so no tears rolling down as somebody flips me the bird or nothing like that, so that's a good sign. A lot of thinking with these problems. I think we should take a quick break. I want you guys to know first hour did not get that brain break, so cool. Yeah, joke's on them. All right, we're going to switch this up a little bit. We're going to do another example, and it's the last example that I have for us, is we're going to estimate or approximate an integral. That was it. I just wanted you to see the bubbles, man. You're welcome to hang out in here, though. You can hang out in here if you want, but we're done with the bubbles. So if you want some calc, you're welcome to chill. Okay, so we're going to approximate an integral here, and I'm going to present it in a very different way. So we're approximating. We're going to make a little table. We have several measurements of times and several measurements of the velocity at that time. Now, this is a much more realistic situation because in the real world, it's not like you're measuring data and it's going to say, oh yeah, here's a perfect equation for your data. You're just going to have a bunch of data points. So let's say we have a bunch of data points, and our first one is at time 0, the velocity was 4, and at time 1, the velocity was 5. And I don't know what sort of recording device that they're using, but for some reason they gave us it at 3.5 seconds. The velocity of whatever we're tracking was 9. And at 6 seconds, it was 6. And at 9 seconds, it was 5. We get this information given to us, which is a much more realistic situation, something that we could time and actually get these data points about. Okay. So for this, we're not doing the exact same thing, right? Because obviously I don't give you a function. We can't find C sub I and all that. As we're looking at this, part A, what I want you guys to try is to evaluate based on this data, this tabular approach. Evaluate, let's say, the sum of f of capital C sub I delta x sub I. Now, there's really an integral happening here, but we're trying to find this out. And this notation is just telling us that, look, we're doing a Riemann sum. Okay, the other day, and every day, rather, when we've taken our integrals, the width of the rectangles has always been the same, right? Has the width stayed consistent here? Like we see a changing width, right? Because from here to here, what's the gap? So my rectangle will be 1 wide. Now, as we look at this, let's use right endpoints. I'm going to say right Riemann sum. And the capitalization was there for the upper sum, I suppose. But let's knock this out. We don't have a function that we can like straight up calculate, but I think we can still add a few things up. So on this, let's just look at these. If we're using the right endpoints, we use the letter u sub I to show at some point in the ith subinterval. This is an ugly way to write my endpoints. What are the right endpoints? So like for this first one, 1 is the right endpoint. How about for the second? 3.5? And I'm just writing commas to list them. How about the third? Ooh, so careful. No, you're right. I'm sorry. My bad. And the last one, 9. We are just using this table to pick the right endpoints. What? Okay. Everybody cool with how we got these? Sweet. All right. So from here, let's just work it out. If we're trying to find this integral, or this area, if you will, let's just do each box independently. What's the width of the first interval? From 0 to 1, what's that width? 1. So we're going to go ahead and just write our equals or approximately equals. We have a width of 1. And what's the height at the right endpoint? I heard 1 and I heard 5. I like 5 more. This is the height at the right endpoint. That's our height of our rectangle there, if we're just using the right points. So there's our first interval. First subinterval. And that one should have been pink, but I just want to make sure we can get it. Okay, let's add the second one. What's the width of the second subinterval? And how? So 2.5 is what I hear. How do I get 2.5? Yeah, we're just finding the difference between them. Okay, so the width is 2.5 and the height 9. I want you guys to finish this. Okay, when you finish this, I have an answer that we can check with it as we need. And then on B, I want you to, it's weird. We're going to define this because they didn't give us a whole lot of stuff. If we're talking time and velocity, and I haven't specified the units, is there a safe assumption you can make? Seconds in meters per second. Are we all okay with that assumption? I should have included it. I did not. Okay, on B, I want you guys to tell me, what are the units? And then on C, and you probably won't finish all A, B, and C today in class. Tomorrow we're going to have a lot of time to work on stuff because I know the stuff that we're doing is challenging. There's not going to be homework, but tomorrow will be like all working on stuff. Okay, so the last question I want you to knock out tonight is explain what we have found explain what we have found with context. So I'm okay if we just say it's a particle or it's a point. Particle is a more common use. The particle that was given velocity in meters per second and time in seconds, I want us to do the sum to really clearly say what the units that we should be left with are and explain our answer in context. These 3 things I want done by the start of class tomorrow. Cool. You guys have like 2 minutes to keep working on it now. I'll let you keep working you probably get A done before you leave. Cool.